make up a whole bunch of these on our own. Okay, we can make a whole bunch of these up that, you know, are totally different from what we have, just that what we've never seen before. But as long as we understand the relationship, we should be okay. Okay, because if I have something, you know, if I show a change in my base, for example, okay, so I'm going to show a change in my base. Okay, so I'm going to go A, and let's put an X in here, X, and our argument is big X. Okay, if I do a change in my base, okay, of let's say I square this, how can that balance off here? Well, I can square here. Okay, and again, this is one I've showed before, where if I change the base and argument, the powers on the base and argument are connected because they are on the exponential form, they are on opposite sides of each other, so they can show up like that, okay, and then balance off. We can show this exponent, right? This exponent here, this exponent A could then be translated into here. Okay, so that instead this could be translated into here. So we end up with the 2 to the power of 2x. So exponent becomes 2x, so the log equals 2x. Okay, so there's these multiple transformations that can be useful, and we can use these to help us you know, manipulate logs in exponent forms. So I'll give another example here. We can, if I start with this, okay, what's useful is, let's say I root the x here. Well, that can show up as a square root here. So again, there's square root, square root. So I'm allowed to do that because it doesn't change the exponent. It doesn't change the exponent form here. Okay, I could also do the square root here, and so let's say I square root the argument. Well, to balance that off, I can square root like that, and that square root on the argument can show up as a square root on the exponent. Okay, because again, if I look at the exponential form, yeah, that square root and that square root are balanced. They're on the opposite sides of the equation, and they can balance each other off. A divide here and a divide here can show up as a square root in there. Okay, that's okay as well. Okay, but what won't work is if I did this, square root that and square root. Well, there's no equivalent to that. Okay, there's no relationship there. So we can, you know, come up with all sorts of these relationships. You know, we can say that we have our argument x, and we have our base a, you know, our exponent of x here, and we can do, you know, all sorts of other changes. We can, you know, what happens if we times? That's one we can investigate. What happens if I times by z, right? Let's use a different variable. I'm going to just times by b. How does this affect what's in here? Well, this now becomes a problem because this times b, how do I express here? Can I just do times b here? No. That's not equivalent anymore because we can't times into the base, because that means b to the power x, and I did not use b to the power x here. Okay, so this multiplying here, that's a bit of a problem. And we should already know this, but let's say we do plus b. Can I do plus b like that? No, that doesn't work. And can I end up with a plus b in here? No, these are not equivalent. This is outside the exponent. This is inside the exponent. Those are different changes. Okay, so those kind of things can't work. Okay, so we could also investigate here. This is the last thing I want to investigate here, is how can I undo that square? What does that undoing of the square look like in exponent form and in log form? Okay, so it's gonna do this. There's my argument x. Oops, where's my argument x? Okay, and then I have my exponent x here. So how does how does the undoing of that exponent work? Okay, if I want to undo that exponent, if I want to get rid of that exponent, I can square root here and I can square root here. That means, again, I can square root. That would be okay. Okay. I could also undo that square root with a divide by 2 here and have those cancel. Okay. And I can, here, if I want to get rid of that square root, I can divide by 2, right? I can divide by 2 here, and then that will get rid of that square. Okay. So again, we can justify a lot of these things if we think of this as an equation and we're balancing off an equation. So just to summarize, when we think of exponents, can addition and subtraction in the base or argument be accommodated by log or exponent? Well, the answer is no, right? Addition, subtraction for exponents is okay, but for base and argument it's not okay. Addition or subtraction outside the log or the exponent, yeah, that's okay. That is what our log rules are, but that's on the outside, right? That's outside the log or in the exponent form. So where was the only place that add, subtract exponents and be accommodated? Okay, so it's when we have the logs are in the log form, either in the log form or in the exponent. And where do we see multiply, divide of exponents? What do they show up and what do they mean? Well, we don't really want to think of divide, okay, because divide really is we only see change a base formula. But if we want to really understand this deeper, there is a multiply, divide. Multiplying is power to power. So if I have log x, that's an exponent, x times exponent log b. Okay. If I want to divide, if I have a divide exponents, log b divided by 2, well, what does that really mean? If I'm dividing a log or dividing an exponent, what does dividing exponents really mean? Well, it means roots. This divide means root. Okay, this divide must also mean root. Yeah, it does. When I actually do some rearrangement of this, it does show up as a root as well. Okay, so divide on the outside of log means root. Divide inside the exponent means root as well. Okay, so again, this is some very deep stuff, and this is, if you understand this, this is really, you're getting really to a deeper understanding and learning of logs.